What's going on, everybody? My name is Eason. Welcome back to another video. In today's video, we're going to be going over Unit 1 for AP Computer Science A. So we're going to go through topics 1.1 to 1.5, and I do have individual videos for this unit. Now, they are the exact same thing that you're going to see now, just broken up a little bit more. So if you're focusing on one specific topic, maybe the first one on printing, then maybe go watch that specific video, or just watch this whole one, because we're going to be doing printing in like all of the lessons. So yeah, we're going to get into that. So let's get started with 1.1. So 1.1 goes over programming in Java. Why we program in Java. So Java is an object-oriented programming language. It's a high-level programming language, so we can do a lot of stuff with it. We use programming languages for functional purposes, and it being object-oriented means we can make objects, and objects are the superior class. I just highlighted that in Java. And here I have class main. Main is my file name, and I have the main class. So my file is kind of like a class. And then here inside my public static void main method, this is the main method we're going to write our codes in. So if we're going to print something out, we do system.out.println. We're going to do it in our main method. So to print something out, we do system.out.println, then a pair of parentheses, and if we want to print out a string, which is basically words and stuff, we put them inside double quotes. And we could say hello world, very generic thing to print out. So we're going to put hello world, and then we're going to end that statement with a pair of semicolons. And then I'm going to run my code, and it's going to print out with a print line hello world. Now we can also remove the ln and just do print. So we can do system.out.print. And since we only have one line of these, the output is still going to be the same. It's still going to be hello world. There we go. Now, what if I want to print another line that says something else? We're going to do system.out.print, and I want to print goodbye world. And I run this. Now, two print statements is going to not start a new line yet. Oh, getting an error because I forgot my semicolon, and I've been programming Java for over a year, and I still forgot the semicolon. So yeah, now print does not make a new line. As you can see here, it says hello world, goodbye world without a new line. How do we do this? Well, one way you could do it is in your first line, you see system.out.print. You can end it with a / and a n right after that. So when we run this again, it's going to start on a new line. Hello world, goodbye world. We could also do this at the beginning of our print line. Our second one, we could do / and goodbye world. And we want to keep the G connected to the N because it's case sensitive. So we had a space there. It will put a space in our output. So yeah, that's one way we can do it. Another way we could do it is, of course, make these both print line statements, because a print line statement ends the line you are currently on. So the first line is going to be ended with our first statement, and it's going to form the second line. And then our second print is going to end the second line and form the third line. So when we print this out, it's going to do system.out.println hello world, start the new line, goodbye world, end the line you're currently on. Because as you can see here, I can put input on the next line. So I'm going to clear that. Very, very cool. Now, what if we did a print statement and then a print line statement? So we're going to do system.out.print, system.out.println. And when we run this, print line ends the line you're currently on. So it's still going to stay on the first line because it's going to end it for the next print statement. So if we do system.out, if I can type .print again, I'll just print world. It's going to start the next line because the first print line statement ends the line you are currently on. So we can see here we have two lines of code. And if I do another print line statement, is it going to start a new line, or are we going to continue on line 2? We are going to continue on line 2. As you can see here, I forget the semicolon. Oh my gosh. Here we go. So when we do this, it's going to still have two lines. We can make this third line print line, and that's going to make a whole other line because it's going to end the line we are currently on and start a new one for world again. So here we have 3 lines, and we've wanted all of these on individual lines. We could just do system.out.println for all of these, and we're going to have 4 lines if we do it that way. Very, very cool. And if you're still having kind of trouble with this, mess around a little bit and kind of type them around. And I'm actually going to put up a sample code, and I want you to determine how many lines it's going to print out. Okay, so here are some lines of code, and I want you to figure out how many lines is going to be printed out. So let's pause the video. I'm about to run my code, and just kind of estimate how many lines are going to be printed out, or figure it out. So we're going to run our code, and it's going to print out 4 lines because we have 3 different print line statements. However, it's going to end the line once, end the line twice, end the line 3 times, and since we have a print statement after the 3rd line is ending, it's going to start the 4th line. Now we can print out other things besides strings. We can also print out numbers, and these are not going to be enclosed in double quotations. So if we wanted to print out a number like 123, all we got to do is put it into our parentheses 123, and it's going to print out 123 as an integer. We did 123.40. Let's do 123.5. How about that? So when we print out 123.5, what's going to happen? It is going to print out 123.5. We can also do math equations to print out. So we can do 120 times 3. Our times is going to be multiplication symbol. So 120 times 3, it's going to print out 360. I'm going to go into math a little bit more in Unit 1 as we go on. But I just wanted to show that. You can also print Booleans, which are true and false. We can print out false, and it's just going to print out false if it ever loads. Right there, false. We could say it's also going to print out Boolean if we do 1 is not equal to 2. And you'll get into these, of course, later. But if you just want to see them, it's going to say 1 is not equal to 2. So it's going to print out true because 1 is not equal to 2. Kind of rhymes a little. So yeah, it's going to print out true there. So yeah, those are some things you can print out. And that ends at 1.1. And now we're going to move on to 1.2. All right. Okay, so 1.2 is on variables and data types. So to start a variable, you're going to put the data type. So let's say we want to make a string variable. We're going to put the name of the variable. So we'll just call this var, V-A-R. And then you're going to hit the equal sign to do some more stuff and give it a value. So let's give it a value. Remember, strings are within close quotations, double quotations. And we just write this is a string, and this is going to be case sensitive, so the only capitalized letter is going to be a T, and then the space is going to be shown if we print them out. So to print out a variable, we can do system.out.println. var is the variable name, and when we print this out, it's going to print out, here we go, one day, this is a string. We can also print out 2 strings, so let's do string, we'll do another as the name, and this is another string. And let's use the same print line statement, and we're just going to print out variable and another. So var and another, we're going to print out both of them, and you're going to probably see that they're going to be kind of conjoined. There's no space between them. There's no period. How are we going to fix this? Well, to add a period to both of them, we just add a period at the end of them. Make sure it's before our quotations end. And to do a space, we have to have a space in between one of the quotations. Now, if we put it at the beginning and end, at the beginning of the second one and end of the first one, we're going to have 2 spaces when we print them out. So we're just going to do 1 space. And let's do it before this starts on another. So here we go. We can do this is a string, and it's going to print out this is another string. And see, we have a space here. Another thing we could do is we can remove the space for both the variables. Maybe we want to print out them one at a time. And here, we can actually put in another string to print out. So we can do var plus a set of closed quotations, double quotations with a space, and then another. So when we print this out again, it's going to print this is a string plus a space plus this is another string. So that's pretty cool. All right, so we're going to move on from that, and we're going to move on to our primitive data types. Can I spell primitive data types? And there's 3 that you need to know for AP Computer Science A, and those are our integers, doubles, and booleans. So integers, these are our whole numbers. Doubles have decimals, so you can think of D and D, and then booleans are either true or false. And we're going to make some variables for these. Yay! Okay, so let's do a variable for an integer, int. These are going to be lowercase. Really, the only variable that's going to be capitalized for the data type is going to be string with the capital S. Everything else is going to be lowercase. So we're going to do integer. We can call this num1, and we can just give it the value of 10. We could do integer num2 and actually give it the value of num1. So what this is going to do is num2 is going to have the value of 10 because it is going to be equal to num1. So we print out with 2 print line statements, num1, and then we do system.out.println num2. It's going to print out 2 lines because we have ended 2 lines. And it's going to print out 10 and 10 because num1 is equal to 10 and num2 is equal to num1. So the value is going to be 10. Very cool. maybe we could do a double as well. So we can do double num1 equals 10.5. Now, when we use a variable name, we cannot reuse this. We can't do integer num1. We can't do that because variable name num1's already been used. So let's write another double num2, and it's going to be equal to 11.0. Now, we can't do double num3 equals 11. We have to have the 0.0. If we wanted to do 11, we can make this an integer num3. So we can print out our numbers, and we'll space them out. So we're going to do what we did earlier with our strings. We're going to space them out by adding a space in our print line statement. So we're going to do num1 plus with a space plus num2 plus with a space there plus num3. And we don't have to put a space there because that's our last number. We're going to put a semicolon at the end of our statement. Make sure you're doing that because I'm sure some people are getting errors by not putting their semicolons in. And there we go. When we print it out, it's going to print out one line because we have one print line statement. And it's going to print out 10.5, 11.0, and 11.1. What if we wanted to separate these by commas? Then what we're going to do is that we're just going to put commas before our spaces start in our strings. And we're just going to add all these together as if they were, strings. Now, what if we wanted to add 11.0 and 11 together? And place that as one number. So we're going to print out two numbers, 10.5 and 11.0 plus 11. So what we're going to do is we're going to remove this comma here in that, string. And what we're going to do is that we're going to do num1 plus comma space plus num2 plus num3. So it's going to print out a number there. So it's going to print out 11.0 plus 11. So it's going to print out the number conjoined together. Now, why is it doing that? It's not adding the numbers together. And I'll show you how to do that in just a second. It's going to just kind of put them together because we have a string here, and it's not really formatted correctly to do that. Plus, the values are different. We have a double 11.0 and an integer 11. So that's just something that you should keep in mind. Now, some other things you need to know about variables is that each variable has associated memory that is used to hold its value. And the memory associated with the variable of a primitive data type, which are integers, doubles, and booleans, hold an actual primitive value. Now let's move on to booleans, and we're actually going to declare a boolean final. And we're going to put boolean after that, and I'll show you what final does in just a second. We're going to give it a name. We'll give it the name value. We're going to set it equal to false. And false is going to be our boolean value because booleans can only return true or false. Now, what does final mean? Final means the value of a variable cannot be changed. So if we reassign value and make it true, it's going to give us an error. And I'll actually show you this error right now. So when I run my code, it's going to see, oh, this variable is final, but we're reassigning it to true. That's not allowed, and it's going to give me an error here. So I'm not allowed to do that. I'm going to have to make another Boolean variable. I'm going to call it value 2, and I set it equal to true. And you can actually print out Booleans as well. And I did this in the 1.1 part. So we can print out val2 plus value, and we can print out, let's see what happens when we print these out together. I want to show you this. So we can print out val2 plus value, two Booleans. We're actually getting an error. You cannot do this. You cannot print out two Booleans in the same print line. You can't do that. So we can just print out one of them. So we'll print out value 2. What's the value of value 2? Our variable name. And it's true. So it's going to just print out true. And true and false have all lowercase letters. Some other languages have a capital F or capital T. Java, you cannot do that. And yeah, that is 1.2 for AP Computer Science A. So yeah, let's move on to 1.3. So 1.3 for AP Computer Science A is on expressions and assignment statements. So a literal is the source code representation of a fixed value. Arithmetic expressions include expressions of type integer and double. So if we do a arithmetic expression, so basically a math expression, it's going to be used with integer and double. And we have different arithmetic operators to do math expressions. So our arithmetic operators include plus, plus, minus, times, division, which is a forward slash. We can do remainder, which is basically a percentage. So yeah. Now, one thing I want to point out, and I'm going to do this instantly, is we're going to make an integer. We're going to call it num, and we're going to assign it the value of 0. We're going to write another integer. We're going to call it j, and I don't think I did this in 1.2, is that we can start a variable, so we have integer j, and reassign it later. So we can do j equals 0, and it's going to assign the value of j to 0. So we can do, let's do another variable. We're going to do integer answer is going to be j divided by num. So it's going to do 0 divided by 0. Now, if we attempt to do this in Java, we are going to get an error. You cannot divide a number by 0 in Java. That's not allowed, so we can't do that anymore. And that's just something I wanted to point out. We're actually going to go back and do integer num again, give it the value of 5. And maybe I wanted to add 5 to it. So what I'm going to do is I'm going to do num plus equals 5. And boom, it's going to add 5 to it. Now, we're not going to see this because we didn't actually print anything out. So that's one way to do it. Another way we can do it, which is how I'm going to do it in the rest of this video 1.3, is going to do num equals num plus 5. So num has a value of 5, and it's just going to add a 5 to it. So we're going to get a value of 10. And this time, I will print it out. So print line num. So when I print this out, it is going to print out 10. Voila. Very, very cool. Let's do a double. So we're going to do double num equals 5.0. Maybe I want to subtract 3 from num. So we're going to do num equals num minus 3.0 because we are using doubles after all. And I will just print out num so you can see this. So 5 minus 3 is 2. We're going to get an error because I did not put my semicolon there. Oh no. So now we can do it again because I don't have any more syntax errors. 5 minus 3 equals 2. So let's convert out 2.0 because it's a double. What if we change the value of num to num minus 3? What's that going to do? Because we're not subtracting it by a double, or subtracting it by an integer. So when we print this out, it's still going to give us a double because num is a double value. Just because we subtract it by an integer doesn't mean it's going to change the data type of our variable. It's not going to do that. It's always going to stay as a double. Num is forever going to be our double in our main class, our main file. Maybe we wanted to multiply num by 3. So we're going to do num times 3, times is the pound symbol, so 5 times 3 is 15, since num is a double, it's going to print out a double, so 5.0 times 3 is 15.0. What if this was 2.5? So num was 2.5. 2.5 times 3 is a double answer, and it is going to get us 7.5 as our answer. What if this was an integer? What if what if num was an integer? Well, for one, num can't be 2.5. So let's set this to 3, and we're going to multiply num by 2.5. Now, if this was a actual math thing, then this would print out 7.5. Now, we cannot multiply an integer variable num by double, unfortunately. However, we can make a variable that's a double and call it num2 and give it the value of 2.5, and we can multiply num2 by num, if I can, as we can see here. And maybe I could try that. Is it going to work? Is it going to work? No, it's not going to work. So you can't actually do that. So sad, I know. Now, let's try doing a remainder. So let's have integer number equals 100. And actually, that's too high. Let's do 10. And we need to divide 10 by 4 and get the remainder. So the remainder is the numbers left over after doing a division. So let's do num equals num remainder of 4. So we're going to divide it by 4 and get the numbers left over. So the closest number that can have 4 go into it is 8. 10 minus 8 equals 2. So our remainder is going to be 2. So when we print out our Java, it's going to be 2. Maybe we can change this value to 5. So 10, the closest value to 10 that goes into 5, that 5 goes into, is 10. So we're actually going to have no remainder if we do it that way. If we do 3, the closest number that 3 goes into is 9. 10 minus 9 is 1. So our answer, our output, is going to be 1. If we divided num divided by 3, so we're going to do / as our division symbol, so we did 10 divided by 3, what's it going to do? It's only going to print out 3. It's only going to print out an integer, no decimal, because this is not a double. If this was a double, we would get a decimal. What if we did this by 4? and 10 divided by 4 is really 2.5. Is it going to round up to 3? No, it's going to round down. In Java, we always round down. So even if an answer to a division problem was going to be 2.99999, it's still going to round down to 2 if we are saving it to an integer variable. Now, what if I wanted to do some more complex math equations? So let's make the value of num equal to 2 plus 5 times 3. Now, in Java, we have to follow Pemdas, and I'm sure you've heard of this in elementary school. So when we do math in Java, math is going to be favored for parentheses first, then exponents, then multiplication, then division, then addition, then subtraction. We're going to get into exponents later in AP Computer Science A, so we're going to focus on that a little bit later when we get into the math class. Very, very cool name. And we're going to focus on right now multiplication, division, addition, and subtraction. So we're going to start doing our math equation, because you might have to do one of these on your AP exam. Is you have to find the value of an integer or the output. So we have multiplication in our equation. So we're going to start with that first. 5 times 2, that is 10. Do we have any division? No. Do we have any addition? Yes. So we have 10 plus 2, and that is going to give us 12. Do we have subtraction? No. So our final value is going to be 12. And when I run my code, it's going to print out 12. Very, very cool. Now, what if I did 5 times 2 divided by 5? So let's do PEMDAS again. Do we have any parentheses? No. Do we have any exponents? No. Do we have any multiplication? Yes. 5 times 2, which is going to be equal to 10. So I can write here 2 plus 10 divided by 5 in my comment. If I want to do division, do we have division? Yes. 10 divided by 5, which is going to be equal to 2. Do we have any addition? Yes. 2 plus 2, which is going to be equal to 4. Do we have any subtraction? No. So we're going to have a value of 4 when we export this, if we ever export this. See, we do have 4. What if I did something a little bit different? What if I did, oops, not a new line, I did these in parentheses. So we did 2 plus 5 times 2 over 5. So let's see this. Do we have any parentheses? Yes. Yes, we do, actually. We have 5. So we actually, yeah. We'll do this in a second. So how parentheses work is you're not really going to do the distributive property, really. You're going to do any math inside the parentheses. So do we have math inside the parentheses? Yes, we have 2 over 5. What value does that give us? 0.4. However, we have an integer, which is called num. Our integers do not have 0.4s, any decimals inside of them. So what it's actually going to do is that it's going to round it down to 0 in this case. So this is going to be 2 plus 5 times 0. Alright, so we did have parentheses. Do we have exponents? No. Do we have multiplication? Yes. So 5 times 0 is 0. So it's going to be 2 plus 0. Do we have any division? No. Do we have addition? Yes. 2 plus 0 is 2. Do we have any subtraction? No. So it's going to have a value of, let's see it, 2. Very, very cool. What if we did 2 plus 5 times 2 minus 5 minus 2? So subtraction's last, and we didn't have any subtraction in the last one, so we just do 2 minus 2, which is going to have the value of 0. And so when we print this out, now we are going to have 0. Very, very cool. Now let's change the value of num to a double. Spice things up a little bit. I'm going to change this to 2.5 over 5, which is the equivalent of 1/2. Make our math a little bit easier. So let's do PEMDAS all over again. Yay! So do we have any parentheses? Yes. Let's do the math inside of our parentheses. 2.5 over 5 is 0.5. So we're going to 2.5 times 0.5 minus 2. Do we have any exponents? No. Do we have multiplication? Yes. 5 times 0.5. That is 2.5. Good. Do we have any division? No. Do we have any addition? Yes. We do have addition. 2 plus 2.5, which is 4.5. Do we have any subtraction? Yes. 4.5 minus 2 is 2.5. Very cool. We're going to run this. Now, something I do want to point out why this runs is that when we do math inside parentheses, inside of an expression, it's going to do the same thing with PEMDAS as well. So, yeah, 2.5 is our final answer. So, if we did 2.5 divided by 5 plus 1, it's going to do 2.5 divided by 5 first and then do plus 1. Even if it was 1 plus 2.5 divided by 5, it's going to do the same thing. It's going to favor the division first over our addition. So that's something you should know about. And yeah, So some things I do want to point out is an arithmetic operation that uses a double value will evaluate to a double value. So it's always going to be double, and anything that uses two integer values will be an integer value. So yeah, that's something I want to point out. And that is 1.3 for AP Computer Science A. Alright, so let's move on to 1.4 now, which is our compound assignment operators. We're going to still use some math. So I'm going to remove these comments here, clear my output from 1.3, and we're going to write an integer variable. We're going to call it num. We're going to call it 10. Maybe I want to increment 10 by 1. So we're just going to do num plus plus, and that's going to increment it by 1. So 10 plus 1 is 11, so we print out num. It's just going to print out 11. Yay! Is it going to do it? Yes, it is. So it's going to print out by 11. Maybe we wanted to decrement it by 1. We wanted to subtract it by 1. So we can just do num minus minus to decrement it by 1. So when we do 10 minus 1, it's going to print out 9. Now, what if I did num plus plus after my print statement? What's going to happen? Is it going to print out 10 because 10 minus 1 plus 1 is 10? No, it's not going to do that because our print statement is before our reassignment of num. So num is going to be 10 after the print statement is run. So it's not going to go back and fix it. If we rerun another print statement, and I'll put a space here because I did not use print line for the first one, it's going to print out 10 again because we reassigned 10 to the value of 10 by incrementing it by 1. So it's going to print out 9 with our first print statement and 10 for our next print line statement. So that is incrementing and decrementing. Now I showed this in the last video. Maybe we want to do it without incrementing or decrementing, or maybe we want to add 2 to 10, which is our num variable. What we can do is that we can reassign num and do plus equals to 2. So we want to add 2, and that is going to equal what num is. So when we print out the value of num, it's going to do 10 plus 2. So that is going to be 12, and it's going to print out 12. What if we did num plus equals to num plus plus, num minus minus? It's basically going to cancel each other out, so it's not going to actually really do anything. We're still going to end up with 12. Very, very cool. And if we remove this increment, not this increment, remove this decrement, so we just have num plus equals 2, num plus plus. It's just going to add 2 plus 1 together, and we're going to get 13. So we can reassign num as many times as we want because the variable is not declared final. So if I reassign this to final integer num equals 10, then we're going to get an error because you cannot reassign final variables. So yeah, maybe we wanted to subtract 2 from this. We didn't want to decrement it by 1. We just wanted to subtract 2. So we're going to do num minus equals 2. So 10 minus 2 is 8. So when we print out this expression, we are going to get, oh my gosh, it's final. I can't do this. Let me unassign it from final. So now when I do it, num minus 2 is going to equal 8, and it's going to print out 8. If we did num minus equals 2 again, let's do num minus 2, so 10 minus 2 minus 2. So 10 minus 2 is 8, minus 2 is 6, so it's going to print out 6. If we can do this as many times as I want, so num minus 2, let's do it a few more times. Num minus equals 2, num minus equals 2, we'll do it 2 more times. Num minus equals 2, num minus equals 2. Now, I've done it a decent amount of times. I've done it 7 times to be exact. Now, you cannot subtract 2 7 times from 10 because you're going to get a number below 0. So is Java going to realize you have a number before 0? Yes, it will, and it will give you a negative number. We can reassign a variable. So we could do integer value, which is not the same name as num, and we can reassign it -5, and it's going to read it as -5. So if we do system.out.println value, it's only giving me like an underline because I haven't done anything with the variable. It's telling me it's useless and not being used, and I don't need to have it. So integer value equals -5. So when we print out this, it's going to register it as a negative, and it's going to print out -5. That's so great. If I increment this value plus plus, -5 plus 1 is going to be -4. So when we print this out, it's going to be -4. That is crazy. Maybe I wanted to multiply -5 by 3. So we can do value times equals 3. So negative 5 times 3 is going to give us negative 15. Because a negative times a positive is a negative. What if we did negative 5 times negative 3? The two negatives are going to cancel each other out, and we're going to have 5 times 3, which is going to be 15. Yay! What if we wanted to divide this answer? So we're going to divide value by, let's reassign value. Let's do something else. So we're going to do value equals minus 10, and we want to divide it by minus 2. So we're going to do value divided equals minus 2. So we're going to do that. So negative 10 divided by negative 2 is going to be 5, because negative 2 can go into negative 10 5 different times. If we did 10 divided by negative 2, so I took off the negative for value, 10 divided by negative 2 is negative 5. So it's going to print out negative 5. We can also do this for remainders as well. So our remainders is our percentage sign. So 10 remainder negative 2 is 0, because negative 2 can go into 10. But if we did 10 divided by 6, our remainder is going to be 4, because 6 is the smallest number next to 10. Not next to 10, is the number closest to 10 that 6 can go into. So 10 minus 6 is 4, so our remainder is going to be 4. So I'm going to put up a bunch of these statements, and I want you to figure out what the value is of value when we print it. Alright, here we go. So I have a bunch of math stuff that we've just covered, and I want you to figure out what the value of value is. Now, it is a double, so keep that in mind that we may have a decimal answer. I mean, we're going to have a decimal answer, but it may not be 2.0 or 3.0 or 4.0 and so on. So keep that in mind when doing this. So yeah. Okay, I'm going to go over this real quick. So we have 16, value plus plus is going to have the value of 17, value minus 5 is going to be 12, and then divided by 4 is going to be 3, minus minus is going to be 2, minus minus is going to be 1, plus plus is going to be 2. 2 times 10 is 20. 20 divided by minus 3 is going to be 6. Now, we cannot have a negative remainder. So 6 times 3 is 18. 20 minus 18 is going to give us 2. And since this is a double, it's going to be 2.0. So when I run my code, it's going to be an error because I did not comment that. Now, if I rerun my code sooner or later, it's going to print out 2.0. It's going to give us a 0.0 because it is a double. Yes, and that is 1.4. So let's move on. So now we're going to get into 1.5, the final lesson for AP Computer Science A's Unit 1, which is casting and ranging variables. So let's clear my output in my console. And what I'm going to do is I'm going to make a value for double. We're going to make it num1 and give it the value of 5.0. Now, I want to do integer num2 and make it double the amount of num1. So we can do num1 times 2. We're going to get an error here because we are multiplying an integer by double. So like if I try to print num2 out, which is supposed to be 10 because it's an integer, 5 times 2 is 10, it's not going to do that. We're going to get an error. Oh my gosh, how do we fix this? Well, we're just going to cast this expression as an integer. And how do we do that? We're just going to put a new set of parentheses before our expression and just write int in there. So it's going to cast it as an integer. So instead of 10.0, we are going to get 10 like we're supposed to. And we get no errors, and it's going to print it out as 10. Yay! Awesome. What if we did this for something else? Let's do integer num1 is equal to 3. And we're going to do double num2 is equal to 5.0. Actually, let's do 5.2. And I want to do num2 is equal to num2 times num1. So, off the top of my head, I know that 5.2 times 3 is 15.6. Now, we are multiplying it by an integer. Do I have to cast it? Let's see. Will it work? Yeah, it's actually going to work. So we don't really need to cast it in this case. So not every case with doubles and integers in the same case with the variables that double will we have to cast it. Kind of just when we have an integer and a double is in our expression. But sometimes you may have to use the double cast to convert it to a different data type. Casting a double value to an integer causes the digits to the right of the decimal point to be removed. And value of type double can be rounded to the nearest integer by using, I'll show you, integer x plus 0.5. Not 0.5, 0.5. So that will round it to the nearest integer up if you need to. And if you want to round it down, you can do integer x minus 0.5. Oh my gosh, I cannot type. You guys can't trust me with computer science anymore. So yeah, if you wanted to do that. Now, I've talked about a lot of math in Java, and are there maximum and minimal integers that we can have? Yes. So to figure out what that is, we're just going to cast a variable with the value of the max integers. We're going to do integer max equals integer in, not all caps, integer with the capital I spelled all the way out, dot max underscore value. So max and value in all caps. And when I print out system.out.println max, this is the maximum variable that you can have for an integer. And I have an error because I'm missing a pair of curly braces. Make sure you have your the same pair of curly braces closing as you do opening, because you might get an error like I did. And the reason for this is because there's only like 4 bytes of memory in Java, so this is the amount of variable that you can have. And doing this so you don't have overflow errors, because if you have a variable that is greater than this number, so we ended this in an 8, we would have an overflow error. Now what about the minimum value of integers in Java? Well, we're just going to name this min, because to make more accurate, and we're just going to do integer dot min. Oh, it's going to make me do the whole thing, underscore value. So we're going to get the negative version of that very, very long number. I mean, it's not so long if you think about it, how many numbers there are. And we're going to get just the negative version of this. And we can increment and decrement this. Actually, let's decrement it, because we have a negative, and we're going to subtract the negative from the minimum. We're going to get an error, ladies and gentlemen. We're going to get a really, really bad error. I'm just kidding. It's not that bad of an error, because we're just going to move from the negative to the positive. So if we did, this is -1. If we did -2, minus equals 2, this is going to change into, watch for it, a 6. So it's not going to continue going. It's going to go straight back to the positive and just move down that train from right to left until you get to the very end of the left as well. And that is 1.5. That is Unit 1 for AP Computer Science A. So if you made it this far, in the link of the description of this video and all my other AP Science videos is going to have a Google Doc to my Unit 1 practice test with some multiple choice questions and a free response question with all kinds of crazy stuff that we've covered in Unit 1. So go check that out. Please like, subscribe. It's free. It really does help me out. The link's in the description down below. And yeah, I'll see you guys in the next video. I'm going to have videos for all the units for AP Science A. Really, really fun. See you guys in the next video. Adios.